Hey everyone, and thank you for coming back to another of our OWASP Northern Virginia meetups. We are so thankful to have all of you here for these virtual hangouts, and we are about to learn all about cloud native top 10 with Mike McCabe. Now, Mike McCabe is the president and founder of the Cloud Security Partners, and he's used his vast amount of experience in the industry to create and implement security solutions for his clients. So I've had the pleasure of working with Mike professionally before, and I'm really excited that you are now here to give us a talk. You are also one of our new chapter leads, and it is really just great to have you on here. So Mike, take it away.
Thanks. Yeah, looking forward to presenting, and let me know when you can see everything.
Yeah, sorry, I can see it all. I have one thing and then I'm going to duck out. So
Okay.
anyone, if you have any questions, just please feel free to put in the chat. I want to make this as back and forth as possible. And Mike, once I duck out of the screen, you won't be able to hear me, but I'll pop back in if anybody has any questions. And when I do, you can ask away.
Okay, sounds good. Slides looking good.
Yep, everything looks good.
Cool.
So see.
Cool. Thanks, Ben. Um, yeah, for anyone who's listening, thanks for joining. Today I'm going to talk about the OWASP Cloud Native Top 10. So, just a little introduction about me. As Ben mentioned, I am the founder, president, CEO, all things at Cloud Security Partners. We're a cloud security and application security consulting group. We work with a lot of different clients, both big and small, to help them kind of engineer their cloud environments better, do security reviews, application security reviews, all those kind of various things. Done a lot of work in helping people move to the cloud in a more secure fashion. And the people who work with me know that I'm very passionate about IAC security. That's just my weird little thing. You can ask me more about that on Twitter. So what are we talking about? We're talking about another top 10. So everyone who's here is probably familiar with what OWASP is, probably also familiar with the top 10. That's kind of the big project that brings everyone into the OWASP fold. One little note I wanted to mention, I was just at the AppSec, the Global AppSec in Dublin for OWASP, where they announced that OWASP is now changing its name to Open Worldwide Application Security Project versus Open Web Application Security Project. So it sounds like they're going to have Pitbull as the official spokesperson, so that's pretty exciting. That part is a joke, but so OWASP has been mostly focused on web application security, vulnerabilities, software, all those kinds of things. They have done a lot in different areas. They've done stuff in mobile. They've done stuff in a little bit in cloud. They've kind of touched on a lot of different areas, but the web has been their big focus area. The top 10 has been kind of the flagship project for that. So the top 10 has always been focused on web apps, but as we know, as we move more of our apps into the cloud off of on-prem servers, the app and the cloud are merging. So there's more of developers being responsible for not only their applications, but being responsible for the cloud infrastructure underneath their applications. And so what I see in the security world is that the expertise, if you're an application security person or you're a cloud security person, you kind of need to know both at this point. They are becoming one and the same. There's still some things that are kind of outside of each's kind of area of concern, but they are definitely merging more and more together. I think of the cloud as all code based. It's all API driven. It's all specs, Terraform, CloudFormation, things like that. So that is code, and there's a lot of automation around how you build out cloud infrastructure, and that's all things that traditionally application security people concern themselves with. So I think of the two as very much aligned compared to what we used to think about with network security, where you were kind of a network pen tester versus an AppSec person. So I think in the cloud, those two things are merging, and they're going to be kind of more of the same. So having both those skill sets is very important. And attackers use both to get access to companies and to data. We see a lot of web apps as the initial point, and then using the cloud infrastructure as ways to pivot and get to more access. So the top 10. This is two iterations of the top 10, 2017 and 2021. And there's actually another version getting worked on. I think it's going to be released next year. They're doing all their data analysis and collection and all that stuff in Brian Glass's Screaming Excel documents right now. So they'll have that out, I think, next year. But what we see is it's still very focused on web applications. So you have things that are, injection vulnerabilities. You have outdated components, software and data integrity failures, server-side request forgery, a very web app focused list of vulnerabilities. Obviously, some things are somewhat cloud focused. I mean, security misconfiguration could be cloud focused. Insecure design could be cloud focused, but for the most part, it's very web focused. And I think that what OWASP is trying to do with their new project, which I'll get to in a second, is have a more cloud focused top 10. So one quick note, there's also the OWASP top 10 serverless. If we didn't need more top 10s, OWASP finds a good thing and just does it until there's too many of something. So we also have the serverless top 10. Again, a lot of very similar things, but mostly focused on serverless. So Lambdas, things like that. This, I think, is also a good area of focus. I'm not sure if there is enough kind of meat in the serverless only area to have an entire top 10 for, but this is also being worked on. So why do we care about cloud security at all? So as I talked about, more and more workloads are getting moved to the cloud. This is from the DBIR from 2022, and we can see misconfiguration is a huge part of breaches. That's not only cloud misconfiguration, but overall. But it's still a big part of what leads to breaches. And they note in the report actually that S3, publicly accessible S3 buckets are a huge part of that as well. So there's a lot of areas where cloud misconfigurations lead to breaches. And a couple data points. Wiz does a great state of the cloud report. I think the first one was released this year or late last year. So I think it's interesting to note, about half companies have one database or storage bucket exposed to the internet, and 20 of those have data that is sensitive. So half of companies have a storage or database exposed to the internet, and a good bit of those have sensitive data. So it's still a big issue that we see of just misconfigurations leading to data leakage or loss of data. So cloud is its own source of issues, along with web applications that have been traditionally, a big target for attackers, and still a very, weak point in people's environments. Web apps are still hacked quite a bit. So what do we have? We have apps and cloud coming together to get hacked together, the perfect union. So with that, OWASP is trying to tackle some of the knowledge gap around cloud insecurities and ways that people should think about their cloud security and areas that they should focus to try to address some of these issues. And that's what we're here to talk about tonight, and kind of go over what this top 10 looks like, what are some examples of it, and my thoughts on the top 10 and where it could go. So we'll just dive right into it. The first one is insecure cloud container orchestration configuration. I'm calling that the cloud kitchen sink because that's a huge amount of different things in different areas. I mean, cloud itself is a huge area that you can misconfigure. Containers are an area you can misconfigure, and then orchestration, such as Kubernetes, that's another whole area you can misconfigure. So that's a very big and heavy-weighted group on its own. I actually think that this could be its own top 10 itself, a purely cloud misconfiguration top 10. So I'm taking donations for that now, if you guys want to pitch in. But when I think about misconfigurations, I think about this chart, which is AWS API Count. So AWS releases new services. Along with those new services, they release APIs to work with them. And each one of those APIs is, typical get, list, describe, you know, all those various kind of actions you do on a service. And each one of those things, all the updates you can do, all the gets you can do are different API endpoints that either have data or give you updates to data. So we have all these services coming out. They all have different endpoints for different configurations. And uh, it's just been an explosion of services in, this is only AWS. This doesn't include Azure or GCP. So it's just been an explosion in services, and those services have different configurations. And I think this kind of just shows when you're trying to secure a cloud, a cloud environment, even if it's just one cloud environment, you have over 12,000 different API endpoints that are kind of factored into it, depending on which services you use. But the point being, it's a huge amount to manage just in this one category. This doesn't even go into the container or Kubernetes kind of side of things. Those each have their own benchmarks that are, tens of pages of things you have to consider. So this area, I think, is especially when it comes to thinking about cloud workloads, is an area that needs a huge amount of focus. We see a lot of work in this area with different software to do assessments in cloud. There's a lot of commercial solutions looking at these kind of things. CSPMs, posture management systems, are all kind of focused in this area, and it's a huge part of cloud security overall. And it really does fit in with the how cloud and apps work together to kind of create insecurities that go from just, say, a SQL injection to an S3 bucket full of very sensitive data being exposed. Misconfigurations in the cloud are just a great pivot point for attackers to use to gain more access. And to kind of drive the point home again, this is a diagram that I don't expect anyone to really read. The point is to show how complex this is. This is a threat model from a group called Trust on Cloud, which I like their stuff, so check it out. This is a threat model of S3. S3, which we think of is a relatively simple service. It's an object store. It's, under the hood, it's very complicated. There's a decent number of features, but I wouldn't call it an insanely complicated service. You put files there, you take files off, you read files, etc. So it's not as complex. It doesn't have as many moving pieces as, say, Kubernetes. But the fact that this threat model is this complex for one simple service, and that's one service of tens that you may be using, it just goes to show that when we talk about configurations and ways to ensure that we have these threats covered, there's a lot to think about, even with the most basic service. And if you're more of a Microsoft Satya guy, this is for Azure storage, which is actually more complex than S3 because it's more than just one service. But the point kind of remains, this is an area that takes a huge amount of work to do right. I think OWASP could build on this quite a bit more to build this out and make it more specific. I think it's an area that people really need to focus on when it comes to cloud security, and it just plays a huge role in the overall security of their cloud environment. So the next one, injection flaws. This one I'll probably spend the least amount of time on because this is well covered ground. These are things like SQL injection, command injection, the typical findings we see in the OWASP top 10. This is closest to the A3 injection category in the web top 10. So this one is, well known. I wouldn't say there's anything that unique when it comes to injection for web applications running on the cloud or running, on-prem or running in just on non-cloud services. It's not really that different. So I'm not sure if there's not really a cloud native swing to it, I guess I would say. SQL injection is mostly the same, whether it's someone hosting Postgres on a server or if it's being hosted by AWS. But there are certain differences, certain things you can't do in the cloud that you can do on-prem. But I feel like this one's pretty well covered, so don't want to spend too much time on it. The next one I think is another, probably after number one, is probably the next biggest area of kind of cloud security that I think people need to think about and that I think is it's good that it's called out in this because it's an area that people struggle a huge amount with, and it has a huge impact on the security of your cloud and your applications. So improper authentication and authorization. So these are things like over permissive IAM rules, policies that give people too much access, um, or just like admin roles being used in an environment that they shouldn't be. Even things like using IAM users versus using trusts and assume roles is a big part of this too. So or just not having authentication on certain things at all. So I think of IAM in the cloud as kind of like a spider web where for certain things it's a very simple relationship. EC2 has a role, but then that EC2 will have access to something that will then have access to something that will then have access to something. Then you get into the whole assume role and then pass role. It's just a very complex area to tackle. And I think it's good that it's being called out as kind of one of the top things that people should focus on when it comes to cloud native applications. We've seen issues where, a public facing web application has an issue that application's running on an overprivileged EC2. The person gets on the machine and they can pivot other areas, or they can do something like SSRF, server side request forgery, get hit the metadata endpoint, get the credentials, and then use that external of the environment. And if that EC2 instance is highly privileged, then there's a lot of damage that you can do. And I think at scale, but even with smaller folks, this is hard to do too. Really having a good paved path for how to do IAM is pretty difficult. It's especially hard when you have hundreds of teams and hundreds and or thousands of applications. But even smaller clients that I work with struggle with this because it's easier just to give people access to get the job done than it is to make very fine-grained roles that they should be using for that individual action they're going to take. So you often see smaller companies just have admin access to everything. At larger companies, what you generally see is they have more fine-grained policies, but there are issues in those policies that they might not realize, or there's trust relationships between different services that allow a lower privileged user or system to get higher privileged access. So this is definitely a big area. One of my favorite examples of this is a SNS access policy. So this is a policy, an IAM policy that's on an SNS queue, topic, that allows anyone, internal, external, in the account, different accounts, to publish to the queue. And you'd say, like, maybe that's not that big of a deal because it's not read data, it's just publish data. But then you have to think about, where is that data consumed? Is that data consumed by a service that does something sensitive? Does that topic receive financial data that could be manipulated if someone was able to publish to that SNS topic? And this is an area where, again, you have IAM users, you have roles, and then you have access policies on individual resources that you have to manage as well. And all of those things together form a very, again, I go back to the spider web, they form a very complex relationship where we're not always thinking about, or it's not always obvious how those things interact with each other and the level of access that we might be giving what's intended to be a lower privileged role or user. So it's definitely a complex area. It's definitely one that people need to think about early on in their kind of cloud journey to figure out how they want to build their IAM model out. So what access should people have? How do you do least privilege out of the gate? Because it is very difficult to claw back privileges once you've handed them out, and it's hard to build that standardization of roles and policies after you have hundreds of workloads using different roles. So definitely something people need to think about. I'm glad it's also part of the top 10 because it's such an impactful part of cloud security. So the next one, this one is a fun one. It's also very relevant. So for those who are not familiar, Circle CI was breached a couple months ago. Circle CI, a CI/CD provider, who generally have pretty high. For some folks, they have low level access to a cloud environment, but for some people, they have very high privilege access. So you could do things like use Circle CI to deploy Terraform out to your environment, where it would need to have highly privileged access to your environment to create servers, create databases, run different scripts. So that was a pretty big breach, and it kind of pointed to CI/CD. Again, that could be its own top 10, and there's some good work going on in that area as well. To kind of talk more about CI/CD security, there's a cheat sheet, I believe, that's being built out. So that's a whole area that people need to really think about when it comes to trust. Again, it goes back to IAM. You're giving something that is automated a high level of trust, and people submit code to it to run with that trust. In the Circle CI case, there's an attacker who had access internally, and just think about if that attacker was able to access every account that Circle CI had access to and the code bases. That's a huge amount of impact. So people need to think about how they segment these things as much as possible and give the least amount of privileges as possible to CI/CD kind of pipelines. That's both if they're internal and external. And then I don't think I need to say too much about SolarWinds, but supply chain management, that's another huge issue. We're all using it, a ton of third-party code, third-party services, along with infrastructure providers. We also have, software as a service provider. So we're using all types of, third-party systems, whether it's pure AWS, Azure, or if it's also SaaS-based or things in between, platform as a service. So that's another big area. Again, those two things could be their own top tens, and you need to do a lot of work in those areas to kind of secure them. This is you have to have a XKCD comic in your presentation. I think that's a rule somewhere. So this is just proven over and over again about how we just have so many packages, so much software being written by people who do it for free, people who do it for the passion, but you pull left pad off the internet and things start falling apart. So have to think about our supply chain and where we get our software that we're incredibly dependent on. So definitely something people are more aware of with work around software bill of materials, things like that, but definitely still an area that needs some improvement. Insecure secret storage. This is a great one, and also, yes, I'm using AI to create some of these images. So if it's weird and creepy, don't blame me. The computer did it. So these examples are things like storing credentials in an unencrypted place. We often see hard-coded application secrets when we do code reviews, or poorly encrypted secrets where maybe you have it in something like a parameter store, but you give wider access to that parameter store than you think you do. Often, running applications have access to a lot of secrets that they probably shouldn't have access to. And we see API keys and passwords just hard-coded all over the place. Pretty much every code review we do, we find at least a test database password, at least some API keys, but worst case, we'll see some AWS keys that are still alive and can still be used. So, this is a huge issue. Again, there's been a lot of work in this area. I think people are definitely more aware of it, but it's such an easy thing to do wrong that it's still done a huge amount. Again, I think this kind of goes back to what I was talking about in the IAM section, which is if you give people less trust and you actually don't give people credentials at all. I mean, that's the great thing about cloud IAM is we don't really have to have true credentials when we have things like IDPs, and we can establish trust via those versus having hard-coded credentials for people. There are ways to tackle this that will improve your level of secret storage and security, but it's still something that people struggle with. Perfect example, access keys for an S3 bucket leaked on GitHub for 5 years, which is pretty amazing. GitHub does do scanning for keys, for AWS keys and a few different types of keys, but this one was out there for quite some time until it was finally flagged. So, um, you can't rely on GitHub to find everything for you. These are things that you have to monitor for, and the better solution is just not have access keys. The more we can just live in like an ephemeral access world, the better we'll all be. The next one, more AI generated art, over permissive for insecure network policies. So this one is very fun because nothing, as much as it is easy to define really well structured networks in the cloud, and there are some amazing features in the cloud that you can use to build pretty fine-grained networks so you can segment things really well. What I've seen and we've seen with working with different clients is as things scale, they just get flatter and flatter. And even though people have kind of these architectures that they build to keep things more segmented on the network side, eventually things just become flatter and flatter. So I think there's a law about this. The level of segmentation of a network is inversely proportional to its size. So the more things grow, the more they just get flatter and flatter. And again, this is something that you can do really well in the cloud because you can automate this. You can automate how you build out networks. You can automate where things should sit in your network. There's some really amazing things you can do with Transit Gateway to kind of have multiple accounts with the right access into the different networks and to keep things more segmented. But it's still, very difficult. Working at a client, working with a client once and being able to ping production servers from a desktop sitting in their office, like that's a Fortune 30 company with tens of millions of security, software they purchased, tons of security people they have, and yet that's still kind of the state of things because as things grow, it's just easier to make it flat and create that interconnectivity than it is to build those very segmented networks. So it's definitely good to call this out and to have it addressed. And I actually think that I think we know egress filtering is a very powerful tool to prevent exfiltration and kind of access out for attackers when they actually have a foothold in your environment. But again, it's something that's pretty difficult to actually do. It takes a good amount of work to maintain kind of what your egress paths look like and what is allowed out and what's not. I wish I had a great answer for this. Honestly, I think that it's something that we'll get better at doing. I think, again, having everything automated, including your network layout and having those proper segments and those proper tiers where app data and front end kind of live help quite a bit to people, so people know where something should go. But we're still seeing issues with this, 50 years into doing networking. So it's just, it's a never ending issue. So this one, using components with known vulnerabilities. Again, this is a very web app focused issue. I'd say there are some parallels with pure cloud kind of security because there's other components that we use in the cloud that aren't just your npm libraries or your Python packages or Ruby gems. Not that anyone uses Ruby anymore, but again, this is mostly a web application issue, and I feel like this is kind of covered earlier with the software supply chain. I'm not sure if they really need both of them. I kind of feel like they fit in together pretty well. But obviously, using third-party software that has vulnerabilities is just another issue that they're all struggling with. There's been a lot of good work, as I mentioned, trying to deal with this. More and more tooling. Dependency Check is a great tool for that. GitHub is building this into their platform that literally for our projects we get an email or we get a notification on Slack and in GitHub that basically Dependabot has pushed up a PR to fix a bunch of out of date or vulnerable packages. You click one button after the test run and your packages are up to date. That said, when you're dealing with hundreds of applications and a huge amount of complexity, things get more complex. and we're just, as an industry, as a software and infrastructure industry, we're just over reliant on third-party software that we have too few people maintaining. So the best we're doing is kind of checking it to make sure it doesn't have any known vulnerabilities, and then patching it as best we can. So this is true in the cloud too, where we're now introducing software to manage our hardware, or our virtual hardware. Terraform, Ansible, Puppet, Chef, all those different kind of software stacks are more software, more libraries we have to manage and keep up to date, and all of them can have their own issues that can open us up to different security issues. So it's not a purely cloud native issue, obviously, but it's definitely still a high priority issue that needs to be worked on. So next one, improper asset management. I think this one is sort of interesting because I'm not sure I know exactly what OWASP is going with this, because I feel like everything kind of falls within that first category of misconfiguration. But I get that people don't know what they don't know. If you go to a client and ask them, give me all your public IPs, depending on how long it takes them to get that answer, that tells you, how much management, how much observation, how much scanning they do of their public facing infrastructure. If you asked a client, how many public API endpoints you have, list me all the public API endpoints. It'd be interesting to see how long it takes them to answer that. For a really, well-run client with documented API gateways, that'd be super simple. For some folks, that would be much more complex. So it's one of those things where for some people, it is definitely a struggle to manage these things and to know what they have on the public internet. And once you don't know what's on the public internet, then you're not patching it, then you're not testing it, then you're not, making sure the underlying system is secure, and that's when breaches happen. So it's definitely an issue. I think in the cloud, it's something that can be dealt with relatively easily, but it still seems to be a struggle. So, I mean, the great thing with the cloud is most things in the cloud can be tagged, and with tags, you can say who owns something, what's the sensitivity of that thing, who's paying for it, which is often the best way to figure out, who owns something. The finance team is going to want to know what budget this EC2 that's costing $100 an hour, what budget that's supposed to hit. So, these things, they have to be done. Asset management has to be done. But sometimes things still fall through the cracks. So it's still an issue that people struggle with. But I feel like, again, going back to the first couple slides, the reason I'm so passionate about infrastructure as code and kind of the security around that is because we can force these types of things to do asset management better by forcing things like tagging, then doing reporting on tagging, understanding, what public infrastructure is tied to certain teams, what applications have sensitive data, do those have anything that's public, do those have privileged roles. You can do a lot of powerful things when you have your infrastructure documented, and when you have assets properly tracked, but it's always still a struggle to get that done. So I think it's definitely a place in the cloud that you can really make inroads. Something that people struggled with on-prem as well. It's not like everyone knew exactly where everything was on-prem. It's just like networking. It's something that's kind of a holdover that we have, I think, better tooling to address, but people still struggle with it because they haven't kind of forced the process and the tooling to be in place to do this well. Moving on to the last few, I think, are interesting. So, inadequate compute resource quota limits. That's definitely a mouthful. Also, I'm not sure why compute is in quotes. Maybe it's not a real computer. But these are things like resources that don't have kind of limits set on them. So, in the cloud, it's super easy to set up infrastructure that is incredibly expensive or do activities that in the cloud that are incredibly expensive. We hear cases about this all the time with people getting their credentials leaked, and then someone sets up expensive EC2s to do crypto mining. it's even easy to turn on an expensive security tool like Macy and then have it start scanning your, terabytes of data, and then you get an amazing bill at the end of the month. So, everyone, I think, if they have a cloud account, has been bit by a bill that they weren't expecting, and um, there's just so many areas you have to keep track of when it comes to this stuff. That can lead to things like what they call denial of wallet, which is basically just racking up a huge bill for someone, or um, just resources that aren't properly bound that cause other issues with performance. So again, it's not uniquely a cloud issue, but it's certainly one to think about. I wish there were better controls around billing, especially in AWS. AWS is kind of will alert you, but at that point you're mostly screwed, and then you're just kind of hoping that the support people will help you out, and give you a break on the deal. Azure has a couple more controls in place that help, but definitely an area that people need to do a lot of monitoring on, and keep track of kind of what's being used. So. And the last one. So this is an AI generated image for improper logging and for improper logging. Very strange. I'm not sure if I really want AI to be our new overlords, but this is what they came up with. So ineffective logging and monitoring. I think this one actually should be. This is kind of one of the top issues, I think. Again, logging in the cloud should be really easy for people because you have things like CloudTrail in AWS that you just turn on and you point to, a bucket or another endpoint to deliver those logs, and you just have the activity in your account. That's not holistic. Doesn't cover everything, but it definitely gives you a lot of insight into what's going on in your account. Then you can have more fine-grained logs for things like different services, ECS, or fine-grained logs on S3, EC2, all those kinds of things. So the issue most people have in the cloud is not a lack of logging. It's really a lack of how do you ingest those logs, and then how do you make use of them. So most people that I've worked with, most clients I've worked with, big and small, they generally have logging enabled. It's just generally going somewhere where no one's paying attention to it. But I always like to challenge people and say, if there was an event, if there was an incident that you detected that was, say, 95 days or 200 days in the past, and you just had something tipped you off that there was an activity, can you go back and trace through the logs to say, okay, this event happened in this web application on 200 days before today. We can track that to our CloudTrail logs, and say what events happened that were correlated with that, and then track to your endpoint logs and say what events happened on those endpoints after that. I'd love anyone to go to work tomorrow and say, like, okay, can I say what happened at this time, on this day 200 plus days ago? Do I have the logs in place? Do I have the level of granularity to really say these things? Because there's been a lot of places that I work that they have logs, but those rotate every 90 days, or less. So they just don't have the ability to go back in time and look at things that happened before then. So they're just kind of hoping that if we get hacked, hopefully we detect it within 90 days, or we're not going to have the level of logs that we need to do a real investigation. So I think it's kind of a combination. People, in theory, should have all logs turned on for everything and just, pump those to S3 and do proper archival rules to kind of reduce your storage. Obviously, you don't need duplication of everything, and some things are unnecessary to have in multiple different places. But I think it's an opportunity to really do a good job of logging when it comes to the cloud, because so much of it is just a point and click, versus a real configuration. But then the work is on the enrichment side and detecting things that are going on and correlating them between different log sources, and being able to do that, over a longer period of time. So, and that really goes into the monitoring side. And I think runtime monitoring is another area where people struggle. I've seen some clients be big on endpoint management and push that out to everything. Then I see some clients struggle to really utilize endpoint management, and just because of the size that they're at, not being able to really make it work. So I think it's kind of a combination of too much logs and not enough kind of insight into what is going on with those logs. So, but that is the top 10. So I had a couple parting thoughts, because I've been doing cloud security for quite some time, and I've done web application for longer than that. So how do we, as I kind of stated at the beginning, cloud and web are kind of combining to be, they're very overlapping. Their concerns are very related. Web application vulnerabilities play into cloud vulnerabilities and vice versa. So I think it's great that OWASP is now thinking worldwide and thinking cloud, and they're they're starting to build more content that is cloud focused. I think it's obviously the way that most companies are going, except if you're 37 Signals who's moving back to hardware. So I think it's good that OWASP is taking a look at this and building out a cloud top 10. It is still in progress, so this isn't a completed project yet. They're still doing data collection and more, getting more feedback on the top 10. I think the top 10 for cloud should be slightly less web app focused. I think we have that very well covered in the top 10. I think they do a great job of getting real world data on web application vulnerabilities and presenting that. And I don't think that their data and what a cloud native set of data would be is very different. So I think what OWASP should focus on is making it more cloud focused, because they have the web application vulnerabilities, then they need the cloud vulnerabilities, and take those two sets together to kind of have a more secure, more protected environment. So I think that's kind of where the project needs to go, and we're getting involved with the project and giving data from the work we've done, and kind of giving our feedback as well. So it's definitely not a done deal. Things will change, I'm sure. But I think that's kind of where OWASP needs to go. It's a good first step, just like the serverless is a good first step, but more needs to be done. And I guess the other question is, do we need another top 10? Is it useful? People like to hit on the top 10 because, can you really distill down every issue we have into just a top 10 things people should worry about? I definitely agree with that. I think that no one should be like, okay, we have the top 10 covered, we can just stop. Like, we don't have any other issues we need to worry about because we have the top 10 covered. Not that anyone actually does have that, but I think it's good to give people who aren't security experts, don't have security expertise, to have a curated list of issues that they should think about first. I think if your applications are not vulnerable to the top 10, you're doing a really good job. I've never seen a single app in the hundreds that I've looked at that isn't vulnerable to at least something, even if that's just something like a insecure package. So I think it does have value for people that don't quite have an understanding of what they should focus on. And I think the cloud top 10 will have a similar impact of, okay, there's a million different things I should think about when it comes to cloud security. Where should I really, focus? And I think that also aligns with things like benchmarks, well-architected framework, things like that. So I don't think it's silly to have another top 10, as much as, people may say that it's not the best way to kind of frame things. Because I think people can use it day to day to just start thinking about where they should focus their effort, and start their cloud security journey. So those are my thoughts on the top 10. I think it's a good start, and it's going to get better. I'm glad OWASP is focusing on this stuff, and I hope that more people get involved to kind of help shape it, give more data, make it more impactful, and useful for the community. So if you want to chat with me, I run Cloud Security Partners. Again, you can reach out to me, Mike at cloudsecuritypartners.com. I'm always available to chat through this stuff. And again, if you want to talk about infrastructure as code, I'm weirdly obsessed with it. So I'm glad to talk about that and talk your ear off. So thanks.
Cool. Thank you so much for joining us and for giving this wonderful talk. I didn't see any questions in the chat, so if you have any, throw them up there. You are still sharing your screen, so I figure I would leave it up there so that way people can catch your email address in case they want to reach out to you for any further questions they don't necessarily want to ask in the chat. But yeah, any while we're stalling for right now, I can just ask you: are there any? What changes would you want to make to the top 10? Just off the top of your head to improve it.
I think, yeah, I think as I kind of said in the first category, misconfiguration, that's such a big category. That's, like I said, thousands of APIs that you have to think about how you configure. So I think they need to break that out into be more to be more focused on different areas.
Yeah.
Encryption, is its own thing, but there's a lot of configurations that are service specific that you have to think about that I think that they could do a better job of breaking that out.
Do you think that has to do with how the OWASP top 10 in general across the board have shifted a little bit? Because they used to be specific findings like cross-site scripting, CSRF, whatever. And then, like you said, you would go into a client and they would say, oh, well, we protect against the top 10. We don't have those specific vulnerabilities where there's no cross-site scripting, there's no RCE, whatever in our environment. We're good to go. So do you think maybe they decided to go a bit more general so that way they could have a bigger umbrella for more findings?
Yeah, I mean, I think you're probably right about that. I think you could probably I think you could probably give up some like number nine about resources. I think you can probably give up something like that to break something out into its own thing. I think also IEM is another area where it's so big that just saying secure your IEM is not like great guidance for people. So I think that's another area that could probably break out into its own kind of area. And I think if you, again, the whole injection vulnerability thing, like if you have, cross-site scripting in the web top 10, you don't have it in cloud native top 10, then why have injection in there? It doesn't make a huge amount of sense in my mind because you're going to have the same vulnerabilities. It's really think about the infrastructure underneath it and then what that stack opens you up to if you do have web application vulnerabilities. So
Sure.
those are my thoughts. I'm just some guy, so OWASP will do its thing.
As they do. So I
Yep.
still don't see any questions in here. We kind of stalled for long enough. So I figure I will give you all back the rest of your night. I want to again thank Mike for coming in, giving us this talk, and for all of you for joining us. And hopefully you learned something. His email address is still on screen. So if you have any questions, please feel free to reach out to Mike. I'm going to say that on your behalf because, that's.
Nope. Thanks a lot for having me. And as the non-speaker role, I'll say we're working on speakers for next month, and hopefully we'll have someone to be in person too. So that'll be
Ooh,
exciting to do another in-person meetup for the first time in a while. And yeah, if anyone
spooky.
has
Yeah,
any questions or
it's been 3 years and 2 months and counting, I think, since we've been.
yeah, so
I believe
hopefully we can
January 2020 was the last in person we did. So,
yeah,
yeah,
hopefully we
thank you
can
everyone for
break
coming
that
in.
streak.
And next month, we might actually be able to see each other in real life. So, have a great night.